454, 4 sum 2. Okay, so we're given 4 arrays. And we have to compute the number of tuples. We have to count. This is a counting problem. The number of tuples that sum to 0. And the numbers, the arrays have all the same length, and the numbers will not overflow. Okay, so let's bring this to the whiteboard. Okay, so to begin with, we're kind of cheating because, you know, this is a binary search problem. And that's okay. Right now we're not training our pattern recognition. We're just training the actual pattern itself. Alright. Oh, I fucking saw it. We need a hash table. Fuck. That was a mistake. Okay, anyways. The two tuples are... Okay, so what's the brute force here? To enumerate through all tuples, right? And how do I find all tuples? we can either choose to find all tuples. We can only choose one number per array, right? Right, because it's one element from A, one from B, one from C, one from D. So we can run, oh nice, this is like a pretty good whiteboard, to be honest. It's gonna be an n to the 4 solution. Assuming n is the size of the input. Loop through I to n. Oh, there's no tabs. Shit. Right? Wow, this is actually a really cool board. But yeah, that's a brute force, right? We're just enumerating through all tuples, and we're guaranteed to get the answer because we're literally enumerating through everything. And all these counters start at 0. It's not like a continuous tuple. Tuples can start anywhere, right? So like here we have I is 1, J is 1, K is 0, and L is 1. So how do we optimize this? So knowing that the topic of this problem is binary search, and we saw that the other topic was hash table, we cheated for this one. What's our repeated work here? Are we recalculating? Are we redoing work? Like we're recalculating sums that we should already know? I'm just gonna recopy this because my drawing is kind of messing me up. Yeah, place the image. They're not sorted. Wait, are they? This example is sorted. All the arrays are sorted, increasing order. But I don't think in general all the examples are sorted. Okay, so can I use any sort of data structure to help me out here? Hash map. Because this is not typical like the other 2-sum, 3-sum questions, because it's not one array. So I don't know if I can use some sort of 2-pointer approach. Two pointers is not going to work here because there's 4 arrays. Like that doesn't even make sense. We have to find a quadruplet. So then what strategy else can we use? Can we use some sort of data structure like a hash map? So then, what else? What strategy else can we? When I loop through and 1 is my first candidate, and then let's say I'm at -2, I know that my remaining sum from C and D has to be the inverse of what I have from A and B, which is 1. Okay, so the fact that this is like a binary search problem means that these input arrays are sorted, but it doesn't tell me they're sorted. Given 4 lists of integer values. Like, what the heck? I wonder what the acceptance rate of this question is. %. So yeah, just a reminder that this solution would be O of n4. So here the two tuples again are 0, 0, 1 and 1, 1, 0, 0. So I'm stuck, so maybe I need to do a bunch of, there's another YouTuber, I forget his name, but this is the potato problem where I've never seen this question and I just need to draw a bunch of examples and see if I can find a pattern. How do I move the actual board? What the heck? Oh, I just zoom it into different places. Got it. That's kind of annoying though. I can't just move around. Oh, here, pan, yeah. So let's draw a bunch of examples to see if you can find a pattern. In general, like hopefully you've done enough practice so that you don't have to do this and you can just recognize the pattern. But sometimes I guess you don't and you need to do a bunch of examples. So what can we do? I'm just gonna like do stuff randomly and hope like I have an answer. I don't know. And I don't even know if this is sorted, man. Like, is this sorted? I can't even do examples because like this question is I'm gonna assume it's not sorted. Okay, so I have my test case. Can I find any tuples here that sum to 0? For 1, damn, this case is too big. I fucked up. Okay, so for this test case, let's see. We have... Can I use different colors here? Not really. There we go. We have this. And we have this. -2. We have -2. Damn, I can't even read this diagram. 2, -2, 2. And we have 0, 2, 0, -2. I don't see the pattern here. I think I have to look at the solution because I'm just really stuck right now. I don't know what data structure I could use. I don't even know what I'm trying to optimize for. I don't know my unnecessary work. My brute force solution is to loop through all possible numbers. Usually hash maps solve the extra looping because we don't have to do lookups. You don't have to do lookups. So what if I stored 2 maps for C and D? Map C maps the numbers to their indices. And we have a map for D. Zero is at the 0th index, 2 is at the 1st index. I have these 2 maps, and then what happens if I loop? Oh, this is annoying. I loop I through N, loop J through N. So, okay, I can do N cubed for sure. I don't know why I didn't think of that earlier. I removed the last loop by processing D first, IJK to N. And check to see if, so like the current sum right now, Okay, why did I not think of that earlier? I was just stuck on trying to... I tunneled on the actual example case, and I should have just recognized the pattern that you can cut one loop with just using the extra space. So, okay, we cut one loop, which is okay. But looking at the solutions titles, it seems that we can do this in n squared. So basically 2 loops. I think I'm just gonna look at the solution. So how can we cut this extra loop? Why do we need this extra loop? We need this last loop because we need to loop through all of C's elements. So is there some sort of data structure that I can use to remove this last loop? Can I use another hash map? The thing is though, is that if I create another map C, then we don't necessarily know, when we loop through I and J, we need to know if negative S can be created from C and D, where S is nums at I plus nums at J. So we need to not necessarily have a standalone map for C, but we need something that says yes, C and D both have numbers that sum to negative S, and here are the indices. Right, because like let's say we processed 1 and -2, so at this point our sum is -1, and we want 2 numbers in C and D to sum to 1, which is the inverse of -1. So if we had loops I through n, loop j through n, we would want a data structure that says yes, one can be created from C and D, and here are the indices 0 and 1. So that makes me think that we need MD but we can't use MC here. We have to build another thing off of MD, which is the possible sums of C and D. This is gonna equal a map. And maybe we map sums to indices. Array of indices. Which is an array of numbers. What if we did that? How do I fucking move this shit? So if I wanted to construct this, how would I do it? I would have to, I don't think I can do it based off MD. I think I would just have to loop through all possible let's say k through n, L through n, we add the sum, which is S, and then arrays indices, like a tuple, KL. Then we have the sum equal to nums at k plus nums at L. Wow, this is cool. I'm actually starting to get some problem solving done without looking at the solutions right away. Bisman, if that's how you pronounce your name. I'm 21. So I'm not that young, like compared to a lot of other YouTubers and people that are doing this LeetCode stuff. I mean, I am young, but I compare myself to a lot of other people in my school and stuff that are already at these companies that I want to get into. So yeah, we add that to the map. Then when we have build possible sums, okay, so this is the n-cube solution right here. If we make some more space, and maybe I'll save these boards for you guys. I don't know if you guys will find this useful, my brainstorming stuff. So this new solution I'm proposing is to build possible sums, CD, right? Then we loop through I through n, loop j through n, and const sum right now is equal to nums I plus nums at j. And then what we do is we check to see damn, there's no tabs in this. It's kind of annoying. If the possible sum CD has the inverse of S, then we can push it to the output. Nums at, so we can do, yeah, we can output dot push nums at I. Oh no, just the array, the indices I, j, and then for just readability, or this is pseudocode, so I'm just gonna push indices. This would be an n squared solution because build possible sums takes O of n squared time the number of pairs would be O of n squared as well, and these two loops would be O of n squared. So time here is O of n squared, space is O of n squared. And looking at the discuss board and just the things, it seems that people are doing this in O of n squared too. I'm not sure if they're doing it in constant time. So let me try coding this up, this solution right here. So before coding the solution up, I'll code the solution up and then I'll analyze how I did on the problem and why I got stuck. And I can't, it's so annoying, I can't, my shortcuts get disabled when I'm in this board. So what we want to do is So what we want to do first is possible CD sums. We'll build the map first. Build possible CD sums, and we'll have to pass in C and D. When we're done that, we loop through A and B. Our sum is the sum. And if the possible CD sums has the negative S, what we'll do is we'll have an output. Return the output. If possible CD sums has negative S, output dot push A, B, I can destructure like this, right? CD equals possible CD sums dot get negative S. JavaScript array destructure. Yeah. And to build possible CD sums, I take C and D and I loop through both of them. And then what I do is S equals, whoops, so this is A at A and B at B, not nums, yeah. And C equals C at C, S equals S, C at C plus D at D. And then we do M dot add S, C and D. And I wonder if my input, if the sums are guaranteed to be unique. Let's just see if this compiles. M.set. Okay, I'm getting the right indices, but my output is not a number. Oh, sorry. We don't even need the indices, goddamn. We just need the count. I'm so stupid, I forgot the question problem. But I mean, it's easy to modify. Our count equals 0, and if this has negative S, then what we'll do is just count plus plus. Then this can just be a set. And just we'll add S, that's it. So that's why there's no, I think the set APIs contains, and I think that's why there was no mentioning of like repeat or anything. Rename this to S set. Oh, that's why. Okay, this returns 4, but it expects 6. So for this input, possible CD sums is a set. And what do we get? We get 0, minus 2, 2, 0, and then just, yeah, like that. So then when we loop through A and B, the possible AB sums that we iterate through are minus 1, minus 1, minus 1, 1, minus 1, minus 1, and minus 1, 1. So it repeats. So minus 1 is minus 2, so we can take 2, that's 1. This is 0, 2, which is minus 2, so 3 and 4. So why is this? Why should this be 6? One, two, why should that be 6? Shouldn't that be 4? I see 3 and then I see 4. I only passed 5 out of 48, so something's very, very wrong. I'm just gonna look at the solution. I'm pretty stuck. This is Python. Okay. I'm pretty sure I got the optimal solution. Oh, there's no count for repeat sums. Fuck. So in this case, when I repeat, CD sum can also be 0 can be formed from either -1 and 1 or 1 and -1 here. So we need to actually, the CD sums can't be a set. It has to be a map that maps the sums to their frequencies. Then, yeah. Okay, I was close. Then once you loop through all AB pairs, you once you loop through all AB pairs, you just check to see if sum exists, and if it does, you add the value, which is the number of times it occurs. So this is a map, and then we m.set s to be sums.get s plus 1, and then we add a default value. Count plus equals possible CD sums dot get minus s. Wow, okay. I feel good about that problem still. I still was able to find, I'm assuming this is the optimal solution. N squared time n squared space. Yeah, double for loops. And I got stuck at the beginning because I got the brute force right away, which is great. I'm assuming I got that in like 10 minutes. But the problem was that after the brute force, stating the simple right here, this n to the 4 solution, I focused too much on heuristically looking at the example and seeing how like I would figure out, you know, how would I do this faster by just looking at the input examples, and I just kind of got tripped up that way. Whereas I should have just recognized the pattern that we can remove iteration with space by just using maps. So once I figured that, I was easily led to the n cubed solution. So from n to the 4, let me draw. From n to the 4, we went to n cubed solution once I hit that. And then like from here on out, this is where I kind of fucked up. But then once I got the n cubed solution, I was like, okay, how do we get n squared? I knew that we could get n squared because I saw this discussed solution. But in an interview, I could probably be like, okay, can we do better? And can we remove that last loop? And we can. And then we went to the n squared solution. So this was fine. And then from here, from me stumbling, this part was fine as well. But this part I fucked up. So I think this is just a case of just more pattern matching and more problems. But yeah. So I will say that I failed that, and we'll do it again.